Hi, this is 15.1, workbook 15 total, and we are going to be talking about circles. This first one is about proofs that circles are similar. So last things that we did with similar is we talked about similar triangles when you have angles, and you have sides and everything. With circles, it is so easy because the only thing that you really need to compare is the radius. So all circles are similar because they all have the same exact shape, and the only thing that's different is a radius. So with these, you're going to be talking about two transformations that have to happen. There's one that will move one center onto the other one, and then one that talks about the dilation. Sometimes it does the dilation stuff, sometimes it does the other transformation stuff first, but it's very easy. So if we had circle A and B, it would move A onto B and then dilate it, making it shrink down so that they are the same circle. And that's what we're doing. That's how you prove them. So you can have reflections. So like this one, if I reflected A over to B, then I can make it bigger and it would be the same. You can rotate it 180 degrees. Is that doing it? Yeah, right here. If you rotate it at 180 degrees, it would be the same, and then you could shrink it. You could translate it down and across. And the main thing that you have to talk about is the dilations. And there's going to be a scale factor where you take the new one that you're trying to put it onto and divide it by the old one that you started with. So it matters the order that they say things. Let's just see this as an example. We have circle A and circle B. This talking about what point it passes through is okay information. And if you did not have a picture, it would be very helpful because you could see that the Y's are the same and the X's here between the 1 and 5 are different by 4. So that means the ray has a radius of 4. But we have a picture, so we can see that A has a radius of 4, B has a radius of 3. And if we wanted to go put B onto A, I can see that I could translate it over. Let's see, from 5 over to 1 would be to the right 6. So translate to the 6 units to the right. And then I want it to go from the small one to the big one. So the fraction is going to have to be bigger than 1 because it's going to make it larger. So that's going to dilate it by a scale factor of 4/3. Could we reflect it across the x-axis? Yeah, but then it wouldn't put it on it to A. So we're just going to leave it with that one. Next one is examine circles A and B. What are some ways, if circle A was translated so its center was on B, which transformation should be performed next to show that the circles are similar? So if it was already translated, so that means a translation, a slide, so that A was on top of B, what comes next? It would have to be a dilation. So A is onto B, and we want to dilate it so it has the same circle as B. Okay, very good. That's it. That's 15.1. 15.2 talks about arc measures. Arc measure is basically part of the circumference. The circumference is the distance around. So A to B, that's an arc. And there are 3 ways of talking about it. So we have AB with a little arc on top of it. In fact, they're showing us here. We can say the words arc AB, and then it is important, and I'm going to talk about this later. We have the major arc and the minor arc. Right now, if I went from A through D to B, that is a minor arc. Usually we don't talk about minor arcs like that. We talk about major arcs. And that would be like the big one, like the Pac-Man version of this versus that little tiny slice. So we have major arcs and minor arcs. We have the central angle. It is equivalent to the arc measure. So we measure arcs in degrees, just like you do an angle. So this this angle, central angle, is the same as that arc measure. And subtend means it intersects it to define a figure using another figure. So we're using an angle subtends the arc, meaning that they have the same things. So we have arc measure. Then we have congruent circles would have the exact same radius. Then they talk about major arcs and minor arcs. And so notice with this one, we talked about major arc because we went through point D that was on the major arc part and back around. And major arcs are minor arcs are way more common. So they'll usually say something about major arc, or you can see in a picture that it is a major arc. Next thing you need to know is a semicircle. It's half of the circle, or in other words, half of the circumference of the circle. Next part is that if you have two angles and you add them together, you can be by the arc addition. Two arcs, you can add them together by the arc addition postulate. And remember that the angle is the same thing as the arc, so it's very easy to do. The whole distance around is 360. So those are all the things that you need to know. We have circle O and we have arc AB. If we wanted to find the measure of arc AB, it's the same thing as that central angle of AOB, so it would also be 71. Next one, we have circle G where the MPN is 270. So MPN, that's the major arc. What is the measure of the central angle that defines that? So MPN, major arc MPN. So if that's 270, the arc is also 270. Nice and simple. Next. Checkpoint 15 only has 4 questions, doing the same type of thing that we just did on 15.1 and 15.2. So again, we have circle P and circle Q. It tells us where those points pass through, kind of as a hint for what to do with the radius. And this one is interesting because the wording is a little bit deceiving. Basically, it's saying, what are the 2 things that we could do to get P onto we have to do 2 transformations. Oh, this one's okay. To get from P to Q. So 2 transformations to get P onto Q. So you would have to, it looks to me like you could slide it over 4. Since the y-axis is halfway between, we could also reflect it across the y-axis. If there was a point right there in between those 2, we could rotate it 180 degrees around. But then we'd have to dilate it. To get from P to Q, you'd have to go smaller. So it had to be a fraction less than 1 greater than 0 to do that. So let's see, 180 degrees about the origin. Nope, that would put it over there. Reflect across the x-axis would put it down there. Dilate with a scale factor 2/5. Well, let's see, this is 4 right here, and that's 2 right there. 2/5 is not going to get us to 4, but 1/2 would. 2 would make it too big. We can reflect it across the y-axis. There we go. So that was the answer we had. Let me go over here again. Dilate with a scale factor of 1/2 and reflect over the y-axis. Next one, we have this JLK. So if this is 154, what is the measure of arc angle JLK? So it's everything that's not 154. So it's 360 minus 154, which would leave us with 206. 206 is the answer for that one. And then this one. This is saying that we have these 2 arcs and then that central angle, but we know that's the same thing as that. We want the angle of HOK. We want to add up all of those. So 77 plus 46 plus 44. 46 plus 44 is 90. 90 plus 77 would be 167. 167 is the answer to that one. And last one, this is the one that's a little bit weird and deceiving because there are 3. I'm just going to tell you that there are 3 right here. It says that if we already dilated it, so it was the same size as B, and then transformed it, what would happen? But that's not what they mean. They're just basically asking what could happen to make them so that we can show that they are similar. So we'd have to show that they're, similar. So we can translate the dilated circle. So its center point is at B. So like we make it smaller and then translate it so that it's down at B. That would do it. Reflect the dilated circle over a horizontal line through point C, because it says that C is the midpoint of AB. So if I drew a horizontal line there and then folded it over the line and then shrunk it, that would be in the same place. Translated the dilated circle so its center is at point C. C doesn't help us find anything about the similar triangles, so that's not going to help. Rotate the dilated circle about point B, would put up below it, still not helpful, but around point C would make it go from here down to there, and that's what we want. Okay, so that was checkpoint 15. Those answers were translated so that the center is at point B. Reflect the dilated circle over a horizontal line through point C, and rotate the dilated circle around point C. All right. That was checkpoint 15, workbook 15. Notice how nice and short it was. We welcome these days. Very good.